It works better if you turn it on. How's that? Okay. I'm going to talk today about a very simple idea from which I've gotten a big payoff. And I'm going to talk about it because it was not only simple but not obvious. Remember when I was a kid, I used to say things like, why isn't this working? Or I can't make this work, or what's going on? My grandfather would say, you didn't hold your mouth right. And then he'd show me how to do it. And I've never been quite sure exactly what he meant by that, unless it was just a nice way of saying you screwed up. But what it's come to mean to me over the years is that there are, for doing anything, there are usually non-obvious features of how to do it well. And so I'm talking about one non-obvious feature that I ran across, how to hold your mouth right in this particular context. The problem is, and any of us who have written GUIs in TK have faced this problem, is that for any given thing you want people to do in your GUI, there are usually multiple ways to do it. And so what I'm showing here, this is a little corner of an entity browser in our application. It's a simulation application, and one of the kinds of entities that we have are what we call force groups, which are groups like the US Army or Al-Qaeda or what have you. In this case, we've got a couple of well-known force groups here. And one of the things you do during scenario preparation in our sim is you create new force groups. So we got the plus icon over there. You push that, it'll pop up a dialog. You can type in all the nice data about the force group, save it. Or you can select Create Force Group from the menu, and you'll get that same dialog, and you can do all of that stuff. So far, so good. Now, of course, you're not always allowed to create new force groups. If you're in scenario preparation, you can create them. But once you've started running the scenario, you're not allowed to do that anymore. So, of course, we need to disable that plus icon. We need to disable the menu items so that they can see, yes, I could do this, but right now I can't. There's nothing more annoying than pushing a button and getting the little pop-up that says, oh, I'm sorry, you can't do that right now. You know, why did you let me go there? So you got to do that if you're polishing your GUI. And as anybody who's tried to do this for a significant GUI knows, it consumes far more of your attention than it ought to. One way people approach this is by using actions, which are something that Brian Oakley wrote about in 2004. There's a lot of information on the wiki about actions. The basic idea of an action is it's an object of some sort. It's kind of like a proc. You can invoke it like a proc and it does stuff. You can enable and disable it. So if you invoke a disabled action, it doesn't do anything. You can associate it with one or more what I'll call user interactions. Buttons, menu items, keystrokes. And the essential thing is that if you disable the action, then you disable the things that are associated with it as well. And that makes your life a little bit simpler because you don't have as many entities to deal with. You know, if you've got one action that is invoked by 2 or 3 different user interactions, well, you disable just the one and there you are. It'll go. Creating actions is fairly easy. I'm using the syntax from Brian's paper, but he points out there and on the wiki that, you know, you're probably better off writing your own action manager with your own peculiar syntax for your own peculiar needs. So you create one rather like you would create a proc, action defined, give it the name, an argument list, and a body. In this case, the body would pop up the dialog I mentioned. And then you can use action associate to associate it with buttons, menu items, what have you. You don't usually need to do an action associate with a keystroke. You just have the keystroke invoke the action, and if the action is disabled, it's a no-op. In our app, we don't use too many keystroke commands of that sort, and so I haven't really worried about that. And then you can enable and they go on, and you can disable and they go off, and you can enable and they go on, and you can disable and they go off, and you know, it's kind of spiffy. But while this simplifies your problem, it cuts down the number of entities you need to deal with, it doesn't make all of your problems magically go away. The new problems you get are where and when. You got to write logic for when these things are enabled or disabled. And you got to decide where to put that logic, which is often not all that obvious. And you've got to decide when to trigger it. In this case, I've got user interactions that are going to be in two different snip widgets. I'll have a snip widget for the browser, and I'll have a snip widget for the entire application window that owns the menu. And so do I want to put the enable-disable logic in either of those? Well, maybe, but maybe not. Maybe it ought to go just in the the application code somewhere. It's really hard to say. In this case, it's fairly global. The state that we are triggering on is, are we in scenario prep or not, which is an application-wide state. So it would make sense to put the logic at the application level. And then when do you trigger it? Well, you trigger it when that state changes. And that's in one nicely localized place. So this action is fairly well behaved. But it's not always the case that that's true. Let's look at this other button, the pencil button that we have here. Once you've created one of these force groups, sometimes you need to edit it. And again, you can only edit it when you are in scenario prep. So we need to have the pencil button go on and on. But on top of that, we only want the pencil button active when you've got at least one of the entities selected, because that's what you're going to be editing. It'll pop up a dialog for that particular entity or for the set of them, kind of like you can do in iTunes, where you select a bunch of tracks and you want to set the metadata for all of them at once. You can do that kind of thing. So that particular button, its state is going to depend on the browser state. So we got two things we got to look at. One global, whether we're in scenario prep or not, and one coming from the browser. Well, okay, it looks like we need to put the logic for this in the browser component because that's where we know the browser state, or we got to do something complicated. So we have an FG update action in principle that's going to depend on the browser state. But then we've got the menu item. And the menu item for it is associated with the whole window. And that window, there could be multiple of these force group browsers on different tabs or accessed in different ways in that one window. The menu doesn't care whether anybody's selected in that browser or not. It's just going to pop up a version of the dialog where you can pick which group you want to edit. That begins to look like we have not one action, but two actions, FG update and FG update from browser, because they have two different conditions. One's only if we're in scenario prep, and one's if we're in scenario prep and we've selected that particular entity. So we've lost a lot of our goodness here. Instead of having only one entity to deal with for two user interactions, we have two user interactions and two actions. It gets complicated. And these are just a couple of examples. I could multiply these. If you've got an application with multiple windows that are each like multiple documents, you could say, with their own sets of entities, well, then the actions need to be applied to the particular windows. And it can get really complicated. And I was trying to make this work, trying to think about how to make it work, when I had an observation, something hit me. Let's suppose each of those green dots represents some user interaction. Menu item, a button, what have you. What we're doing by defining actions is we're partitioning those set of buttons and menu items by what they do. So for example, over here, on the right, I've got this oval here. We've got three user interactions that are all doing one action. We've got next to it, here are two user interactions that are doing one action. We've got a lot of singletons, actions where they're one for one with the user interaction that triggers them. So we can see there that where we're making the programmer's job easier in terms of enabling and disabling these things by defining actions is we're partitioning this set of user interactions in a useful way. But then I started thinking, two conditions, two actions. What if we started thinking about this by the conditions for which the actions or the interactions should be enabled? Well, it's not going to be any worse than partitioning it by action, because for any given action we have one condition, when you can do it or not. But it may be that we have lots of actions that share the same conditions. For example, are we in scenario prep or not? And I can tell you, I've got, I don't know, 5, 6, 7, 8, 9, 10, I'm not even sure how many different kinds of entity that you can edit in this simulation that all depend on whether you're in scenario prep or not. And you can create a new one whenever you're in scenario prep. So those all have the same condition. So we could partition it down maybe by quite an awful lot and deal not with all those little dots or all those ovals, but maybe just with those 4 big rectangles, those 4 big sets, and deal with them all at once. So that's the idea. We're going to define an object for each of those conditions, whatever they are, and we're going to associate the user interactions with those conditions instead of associating them with individual actions. Now, a bit of a digression. The way we're going to do this, buttons, menu items, such like, they have a state option. And if the state's normal, then they're enabled, and if the state's disabled, then they're disabled and they turn gray or they do whatever they do. So the real problem we have here is we want to control the state of these particular things. So I elected to call this object I'm going to create a state controller, hence the name of the talk. Here's what a basic one looks like. This is for the plus button that we have. I define a state controller object. This is done with snit, of course. Nothing particularly snit dependent in here. It's just, of course, what I use. So I'm going to define one called in prep. Are we in the prep state? And I've got a minus condition option whose value is a Boolean expression. As we see here, I have a sim module with a state subcommand that returns the current state of the application. And if that state is prep, we're in the prep state. If it's not, we're not. I then ask the in prep object to control that plus button. I'll do that when I define the plus button. And then when I want to enable or disable that plus button, when I know that the state has changed, I just say in prep update. And I can have in prep control any number of buttons, menu items, whatever you like, as long as they have that minus state option to be normal or disabled. And I put that in prep update call in my sim wherever the state changes from prep to something else, which is fairly localized. And all of those widgets magically change their state. I'm not going to show you the implementation of this. We're not making it publicly available, but you know it's not a whole lot of code. This is trivial to write. There are any number of people in this room who could put it together in an hour. As I say, this is really a trivially simple idea. It's just I've gotten a huge payoff out of it. Now, here's the more complex case I talked about. Here, what I care about is that we're in scenario prep and that at least one thing is selected. So I use a slightly more complicated expression. Sim state equal prep, and the length of the browser's current selection is greater than 0. But wait a minute. Where'd that $W come from? How did I get a $W in there? The state controller object is presumably global. How does it know which browser we're dealing with? Well, it's magic. When you ask it to control a particular widget, particular button or what have you, you can pass in effectively a dictionary of values that can be used in the condition. So in this case, when I associate the pencil button with the controller, I pass in whatever the name of the widget is, whatever the name of the browser widget is. And then my condition can include whatever predicates it needs to that involve that browser. And I can have multiple objects getting passed in if I need to. I think the most I've ever actually used is 2, but you can do as many as you like. What that means then is that even though this state controller involves state from two sources, from the application as a whole and from a browser, I can use this for all of those half a dozen or a dozen browsers that have pencil buttons like this, and use the one state controller for all of those cases, even though they're all different browsers. Let's look at where and when again. Where do we put the logic? When do we trigger it? Well, where? In the state controller, of course. That's what you've done. It's handling all of that logic for you. But when do you trigger it? When do you look to see if the state ought to be changed? Well, you do that on notification and whenever else necessary. Say what I mean by notification. We have a mechanism in our app called the notifier, which is basically sort of a non-GUI event binding mechanism. Any object can send out any number of events whenever it wants to through the notifier. Any number of objects can subscribe to any particular event. It's a managed callback list, effectively. And so what that means is, in this case, the simulation object, whenever the state changes, it sends out a sim_state event. Any number of modules in the program, any number of objects can subscribe to that. It doesn't care who they are. And when it's sent out, they can look and see what the current state is and do whatever they want. So what we did in our implementation was we added a -events option to the state controller, which is just a dictionary of object names and event names. And it will automatically subscribe to all of those events, and when those events happen, it'll trigger the state controller to update all of the things that are controlled by it. And this is really nice because it means that the where is in one place. Wherever in my app I decide to implement my conditions, I usually put them all in one place. And the when is specified in that same place instead of being sprinkled hither and thither all around the code, which is what happens if you don't use some kind of callback mechanism. I could have just paired this with a bunch of notifier bind statements that would call prep and cell update explicitly if I wanted to. But it was easier just to define the events option, let it do it automatically. That's why I say, if you use this technique, you're going to want to define your own state controller because you're going to have your own infrastructure and your own quirks that you're going to want to put in it for convenience. And then, unfortunately, in the browser, when its selection state changes, we're going to have to arrange to call prep and cell update because otherwise it's not going to know. I do have an efficiency thing in there that I don't know how important it really is. But when you call prep and cell update, you can pass in the name of the specific widgets that you think are going to get updated. So the browser can pass in the ones that it explicitly owns, and prep and cell will not try to update anything else. But I suspect that that's fairly inconsequential in terms of the actual performance. I suppose you really want actions. The state controller can control actions as long as they've got a -state option that works in the normal way. So if you were to implement your actions using SNIT, you could give them a -state option, and then you could control them with this. We've not found any particular reason to do that, but you could combine the two techniques. So I thought this is a really neat idea. This is going to give me all kinds of benefit. You know, I could take all of these user interactions down and collapse them down to just a few conditions. How did it work out in practice? Well, our application has about 75 what we call orders. These are commands that make significant changes in our simulation model. Those 75 orders are triggered or invoked by about 150 user interactions, which is interesting in that that's about a factor of 2 to 1, which is about what I've seen between actions and user interactions as sort of the normal ratio. And that's per application window. We can have multiple application windows. There's only one scenario running at a time, but it allows you to have multiple views on the same data. They're all pretty much identical, all the windows. They got a lot of tabs, and you pick what you want to look at. But you can look at two things at once that way. So we've got 150 times n user interactions total. So how many conditions did I need to tame this beast? 8. 8 global conditions. They're not per window. They're defined just in my main routine. There they are. And all the various GUI components will just make use of them and associate themselves, and it just works. It works so well that when I had to add a new one, I'd forgotten how. I had to add a new one this summer, and I was thinking, well, I've got to make this thing enabled and disabled properly. How do I do it? Oh, yeah. Yeah, I fixed that. And then I had to go back and look and say, oh, here they are. Yeah, okay, I can add another one. So I added 7 in the first couple of months of using this. And then finally, a year later, added 1 more, and I haven't used it anymore. So as I say, very simple technique, really big payoff. Those few of you, apparently, who are still doing TK programming might find it useful. Whether it would do anything in WebTK, Steve, I have no idea. So, any questions?
Can you go back a slide to the WinWare Revisited? For the browser, instead of using the browser update, when the selection happens, if when you added that one in, where you specified the widget name, W and the widget name, you could have had a minus events. You could have done a binding to the selection, the virtual angle bracket selection, and add to the events that this monitor. Right? Wrong?
You know, that's an interesting thought. It would have to, whenever you associated something with it, you'd have to have that $W in there so it knew who to subscribe from. But that's a good idea. That would make my life simpler. Thank you.
Okay, I was wondering.
No, that hadn't even occurred to me. That's a great idea. Anything else?
We have a similar mechanism where we can define events on different windows or widgets where we can register callbacks to trigger. So I always view that as sort of that virtual events could almost, virtual events seem to be designed to target one location, where this is more of a broadcast. Or
yeah.
I was wondering if there was something like that should just be put into the core kind of massive broadcast mechanism.
I'd certainly appreciate it. I find that for GUIs in particular, but for other apps I've used as well, it's really nice to have what I call an order event architecture, where you have your orders defined for inputs coming in, and then in response to the inputs coming in, the modules there will send events out that they get broadcast. And then in terms of dealing with output, in the other application we have that I've talked about in past years that Ted's going to be working on, we have 2 bridges, the RTI bridge and the client bridge. One talks to the federation of SIMs that our SIM is associated with. The other talks to the GUI workstations. They're separate apps that talk across sockets. And then we have the core simulation inside. And so the bridges use orders to talk to the main SIM, and the SIM uses the events to say that things have happened, and the bridges get those and send the data out. And it's a really nice pattern. And we're using the same thing here in this app. And if it can be supported in the core, that'd be great.
One of the state controllers here have defined as a normal and disabled, depending on the condition.
Yeah.
But we have, in particular, we have some tri-state widgets, normal, disabled, read-only. Have you found any use for extending this where you say condition, state, condition, state?
What would I have done instead, since I have SNIT, and I can use SNIT, is it's easy if I've got a widget that's not behaving quite the way I want to wrap it and make the minus state option do what I want. And there are cases where we have done that, where we really want read-only and disabled rather than normal and disabled, for example. On a combo box widget, for example, read-only lets you just pull down the menu and pick things, but not edit it by hand, and that's usually what we want. So I often find it useful to use SNIT to wrap up widgets to give them the interface that I'm looking for, and that's the approach we take.
I was kind of thinking more of where, like text or an entry, where you might want it disabled, you might want it read-only, so that it can select it and all, but and you might want it normal.
Yeah, we've not had any cases where we needed all 3 states.
Okay.
That's why I say, write your own. It's easy to do, and you'll have your own quirks. Anything else? Thank you very much.